Good afternoon, everyone. I would like to welcome you all for today's MIU. My name is Hari. I am Research Associate in the Sea Traffic and Nautical Solutions Department. Before we begin, I have few important announcements to ensure smooth session. First, I want to thank you all for joining us today. Please remember to keep your microphones muted throughout the presentation to minimize the background noise. We also kindly ask you to turn off your cameras as we'll be starting our video recording of this session. Lastly, if you have any questions, please use the hand symbol to indicate your interest or feel free to speak directly at the end of the presentation. Now, without any further ado, I would like to hand over the floor to my colleague, Ashwarya Kumar. He is a senior research associate at the Sea Traffic and Nautical Solutions Department. He has major experience in maritime simulation networks, and he will be presenting on the topic enhancing nuclear emergency preparedness in the maritime Arctics, the role of simulation networks and the advanced data tracking tools. Thank you. Ash, the floor is yours.
Yeah, thank you, Hari. The first question, am I audible clearly?
Yes, Ash.
Great. Yeah, good afternoon, everyone. I'm here to discuss on this very lengthy topic that is enhancing nuclear emergency preparedness in the maritime Arctic, where we will see the importance of the simulation network and advanced data tracking tools. Our focus will be on using...
Ash, 1 minute. You're not sharing your screen.
Oh, I'm sorry. Is it okay?
Yes.
Okay. Yeah. So yeah, our focus will be on using simulation technologies to prepare for scenarios that would be nearly impossible or very tough to practice in the real world conditions. For today's agenda, I will first try to explain the current nuclear maritime risk in the Arctic, also try to provide some insights on the factors for the increase of maritime movement in the region, followed by the unique navigational challenges that the region brings up. Then we'll examine how simulators, particularly within the EMSN network, provide solutions for training and preparedness. I'll also discuss advanced data tracking integration of the tools and would share practical exercise examples. Some fact check first. So the Arctic region is experiencing an unprecedented growth in maritime traffic. The Northern Sea Route Administration reported 34.9 million tons of cargo transported in 2023, which is a 15.8% increase from the last year. So Russia currently operates 5 nuclear icebreakers in Arctic water with 2 additional vessels under construction, which is going to come in picture in 2026. If I'm not wrong, they have this the floating water nuclear plant, which represents a new category of nuclear asset. According to the Arctic Council PAME working group, there is a 37% increase in ship movement in the last decade. When focusing specifically on nuclear maritime risk factors, PAME observed a 23% increase in unique vessel between 2018 to 2023. According to Lloyd's list, they have documented 14 significant maritime incidents in 2023 alone, which involves 5 vessels carrying hazardous materials. Perhaps most concerning from an emergency preparedness perspective are the findings reported by Marshenko and colleagues. Their research revealed that 68% of the Arctic shipping lanes have emergency response times exceeding 24 hours. This is certainly an alarming stat. Looking to the future, models developed by Aksenov and his team projects a 42 to 67% increase in Arctic shipping by 2030. But for what reason there is increase in the traffic? The PAME attributes this projected growth to 2 main factors: increased natural resource extraction activities and the ongoing decrease in sea ice extent, particularly the loss of older thick ice. These changes have significant implications for longer navigation seasons and are easily accessible to previously difficult to reach regions in the Arctic. Building on what we have seen about the increasing Arctic maritime traffic, let's examine the unique navigational challenges that directly impact emergency preparedness for nuclear vessels in that region. So according to the National Snow and Ice data, they have documented a 15.3% decrease in sea ice extent per decade. While this creates more open water for navigation, it also generates more hazardous conditions due to unpredictable ice movements. Marshenko and Bosch documented cases where conditions change from open water to impassable within just 48 hours due to sudden wind shifts. In the highest latitude, vessels must navigate up to 179 days of darkness annually, according to IMO Polar Code guidelines, which indeed further complicates safety operations. Communication infrastructure remains severely limited, creating critical gaps in emergency response capabilities. The International Association of Maritime Communication reports 42% of the Arctic water have unreliable or no satellite coverage. But the most concerning part is explained by Fedjorta. I'm sorry if I'm taking the name wrong, but yeah, and colleagues, where they have identified critical GMDSS, which is like Global Maritime Distress and Safety System, coverage gaps above 75-degree north latitude, which is precisely the location where most of the nuclear vessels are operating. Erickson and Avon documented how extreme temperatures between -40 to -50 significantly affect the equipment reliability. These challenges make conventional emergency preparedness or response planning insufficient, particularly for nuclear vessels where consequences are magnified. So the main question is, how can this nuclear emergency preparedness in the Arctic be tested and verified? The idea will be to achieve a technical, stable, and proven approach. That is where the simulators come into the picture. Following our discussion of Arctic navigation challenges, maritime simulators provide practical solutions for nuclear emergency preparedness. These simulators allow participants to safely practice worst-case scenario like radiation emergencies with zero risk, navigate extreme Arctic condition, and can master procedures through repetition of the process. Training on simulators can directly address Arctic-specific challenges. Something like testing protocols across varied ice and maybe weather condition, or practicing communication during high latitude where the system generally fails, and offering new emergency responses techniques. Other benefit of simulators where you can measure the performance improvement. We can record all decision for detailed assessment. We can certainly identify procedural weakness. We can observe by comparing different methodologies across different participants. And also we can validate emergency protocols before real-world implementations. So a view from our simulator, which represents the harsh weather condition and a distress ship in front of our own ship somewhere in the Arctic region. So this looks very fun. It looks beautiful, but generally, if you can think of that situation when there is a distress ship and you have a very harsh weather, you don't like a real kind of scenario going there and testing it. So we looked about the advantage of simulators, which is localized light. Let's think about having the benefit of doing an advanced level of training with multiple partners who are experts in their own domain. The benefit of multi-organization training reveals let's say coordination gap that stay hidden during solo exercises. Team practice real communication between agencies and vessels. They can solve authoritative issues before real emergencies happen. Most importantly, these exercises build understanding between emergency personnel from different organizations. While doing joint exercise together, everyone can test actual resources, capabilities across agencies. And teams can spot gaps between emergency plan and practice making through decisions with limited resources. By working together, organizations naturally develop common procedures and terminology or a standard reporting procedure that can have written agreements which can be tested before any real emergencies occur. Let's say that taking bigger picture in mind of having collaborative way of performing exercises, we have an approach, which is EMSN, that is European Maritime Simulation Network, where it provides infrastructure for maritime training beyond geographical limitations. So EMSN connects multi-maritime simulation center using encrypted communication through secure links. enabling distributed exercises where participants exercise identical environment conditions and creating a realistic multi-vessel scenario. The location-independent capabilities remove geographical barriers to multinational training. Experts participate regardless of physical location. This includes specialized Arctic Simulation Center with environment modeling capabilities critical for nuclear emergency exercises. Participants access scenarios and expertise from the unvaluable at their individual facilities. EMSN continues developing its capabilities with ongoing improvement to match the increasing complex maritime environment. The network maintains a growing library of emergency scenarios based on the historical incident and projected risk. It has the capability of integration of a real environment monitoring system that reflect actual Arctic conditions. I will not go to the technicality of how EMSN works as it is beyond the scope of today's presentation, but the overview or the technical architecture to connect multiple simulators irrespective of the geolocation looks like this. Building on our discussion of simulator network, let me highlight the advanced data tracking tools that further enhance emergency preparedness in the Arctic. So our tool can automatically create exercise scenario. We need to input some key parameters and the system generates the exercise scenario on its own. This ensures consistent training scenarios and saves significant preparation time. The tool integrates real-time AIS and can also accommodate the DIS data streams, showing actual vessel movements during exercises. It also is capable of identifying the collision risk and can generate alarms. The tool also provides some mathematical modeling for hazardous material release, which visually displays contamination spread based on the current weather condition. It is still in progress though. For emergency responses, the tool can place virtual distress vessels anywhere in the Arctic water that appear on all network simulators. It automatically calculates optimal response routes and so an upcoming update will add automatic notification features for responsible agencies with specific pre and post incident requirements. The tool is also capable of showing a hazardous gas release modeling animation with ongoing development to improve its accuracy. This allows team to practice response in visually represented contamination zone, which is especially crucial for nuclear emergency preparations. That's an example of two complex scenario exercises created by the tool itself. So this is one of the ongoing project known as Atomics. This is our tool Mosaic, where we are developing and conducting our testing. On the right, you can see the data directly coming from the VTS Center in Norway, which is a vehicle traffic center, which provides a real-time AIS ship information. In the center, we have a ship that provides information for the predicted position, and it can also generate the alarm, of course. On the left, we have the emulator that can create a distress signal for a ship. It can also send distress ship information to the simulator and can be shown on the simulator in the whole network. Currently, we are working on modeling that can be sophisticatedly animate the release of hazardous material into the atmosphere depending on the weather condition and can simulate it in the tool itself. We will try to find methods to incorporate this feature into the simulator as well, but this is an ongoing project. Hopefully, we will have a better result in my next MIU. Yeah. To summarize our key points, so the Arctic region is experiencing unprecedented growth in maritime traffic, including nuclear vessels. The unique challenges of this environment are unpredictable ice conditions, limited communication, and extended response times that certainly makes conventional emergency preparedness insufficient. Maritime Simulation Network offers a powerful solution. They enable safe practice of high-risk nuclear scenarios. Multi-partner exercise further enhance preparedness by building coordination capabilities, testing resources allocation, and developing standardized responses. Our advanced data tracking tools complete this preparation ecosystem through automated scenario generation, real-time data integration, and enhanced coordination features. These tools create training experience that closely mirror the complexity of the actual nuclear emergencies in Arctic waters. On the right, you can see the list of partners in Atomics project. Currently, we are working with them. And yeah, for conclusion, looking ahead, we must focus on fully integrating this hazardous material modeling across our tools and, if possible, on the simulator itself. Expanding participation to include all Arctic expertise and developing standardized protocols specifically for nuclear emergencies in these challenging waters, making a pre and post requisites in case of the emergency. The rapid increase in Arctic shipping, particularly near nuclear vessels, demands proactive preparation. By leveraging simulation networks and advanced data tools, we can develop the specialized emergency responses capabilities needed to ensure safety in the critical and challenging environment. And yeah, I think that is all from my side in the presentation. Thank you so much for your attention.
Thank you, Ash, for your insightful presentation. Your exploration on the simulators in the Arctic region was truly insightful. Now I would like to open the floor for any questions. If anyone has a question, please use the hand symbol to indicate your interest or feel free to speak directly. I think it was a well-made presentation. In case there's no questions, then I will ask Ash. Maybe I have one question for you. Have you developed any structured framework to identify and classify this hazardous condition in the Arctic region, including any, do you have any like kind of a dependency list for the risk factors?
Yes, we have initiated the development of a structured framework to identify or classify these hazardous conditions. But our partner team is creating this comprehensive dependency list that evaluates in various different conditions and various different category of emergencies. From them, we will try to integrate in our tool. So whenever there is a condition or there is any emergency, we will try to make a list and we will try to put the pre and post requirements or with the agencies whoever is responsible for that particular situation.
How will you try to connect these things into this EMS network?
Um, Currently, it's a very small requirement. We just need a simulator on the centers. We can connect and we can perform the exercise in the whole network. And it's easier to connect, let's say.
So if there's no questions, then if you have any questions further, you can write to Ash anytime. And thank you once again for joining us today. Our next MIU will be on 25th of April. It will be it will be done by one of our colleague Pascal. It will be based on analysis of eye tracking data for the ship handling simulators. I look forward you all to seeing on another topic on 25th of April. Have a great Friday and a wonderful weekend ahead.
Have a nice weekend. Thank you all.